Welcome! Today, we are mapping out one of the most exciting adventures a young learner can take. We're talking about the journey from their very first simple coding blocks all the way to writing powerful real-world code. So, if you're a parent or an educator looking into coding for kids, you've probably hit this exact question. It feels like this huge fork in the road, right? Do we start with the fun, visual world of Scratch, or do we jump right into a real language like Python? It can feel like a really tough choice, but here's the good news. You don't actually have to choose. And this is the key insight, the thing that changes everything. This isn't an either-or situation. Thinking about Scratch versus Python is kind of like asking if a kid should learn to walk or learn to run. It's not a competition. One just naturally follows the other. It's all about building skills in the right order to build confidence and hopefully a real love for creating with code. Okay, so let's start right at the beginning of that sequence. The first step for most young coders out there, especially kids between, say, 6 and 10 years old, is the wonderfully creative and super intuitive world of Scratch. You see, Scratch uses what's called block-based coding. And honestly, the best way to think about it is Legos. Seriously. Instead of typing out code, kids just drag and snap these colorful blocks together, and each block is a command. This whole visual approach just gets rid of one of the biggest roadblocks for beginners, the frustration of typing and getting syntax perfect. And right here, you can see the absolute genius of Scratch. On one side, it's teaching the core concepts of all programming. I'm talking logic, sequencing, loops, conditionals. But on the other side, it cleverly lets kids completely avoid the stuff that makes most beginners want to tear their hair out. Syntax errors, a forgotten semicolon, all those little details that can just stop you dead in your tracks. It's basically a playground for learning logic, without any penalty for typos. But after a while, after mastering that playground, there comes this really pivotal moment. It's that moment when a child is ready to move from the visual world of blocks into the truly limitless world of text-based code. So, the big question is, how do you know when it's time to make that leap? Well, you just have to watch for these clear signals. Are they kind of hitting the limits of what Scratch can do? Or maybe they're getting a little bored with it. Are their typing skills getting pretty solid? Are they building really complex projects all on their own? And here's the big one. Are they starting to ask, so how do real programmers do this? If you're seeing these signs, trust me, they are absolutely ready for the next challenge. And here's the payoff for doing it in this order. Get this. Kids who have a solid foundation in Scratch actually learn Python 30 to 40% faster. Now, why is that? It's because they've already mastered the logic. They aren't learning two massive things at once. They're just learning a new language to express the coding ideas they already understand.
And that brings us to Python. This is the text-based language that powers so much of our modern world. This is the point where a young learner really graduates from an educational tool to a professional-grade instrument.
Now, the shift from Scratch to Python, it's a big one. You're going from a visual interface to typing out text. The recommended age jumps up. But look at that last row. That's the real game changer. You go from building fun games and animations to building things like AI models, powerful apps, and the very websites we use every single day. And I'm not exaggerating here. The AI behind assistants like Siri and Alexa, Python is a huge part of that. Those recommendation engines on Netflix and Spotify that know what you want to watch next, Python. It's all over game development, robotics, data science. This is the real deal. And, it's incredibly motivating for a middle schooler to know they're learning a tool that professionals are using to solve huge problems. So, where can a young coder start this next chapter of their journey? Well, the great news is there are some fantastic, totally free platforms out there that make it easy to start practicing Python right now, without any complicated setup. For a kid who's just graduating from Scratch, one of the absolute best first steps is a platform called Trinket. It's really designed to make that transition feel super smooth and familiar. Trinket has some awesome features for making this leap. For example, it has a remix function that works just like it does in Scratch. Kids can find someone else's project, make a copy, and just start tinkering with it immediately. It all runs right in the browser, and its Turtle graphics library is this perfect bridge for visual learners who want to see their code come to life on the screen.
Now, if your child is really motivated by making games, and let's be honest, a lot of them are, then PixelPad is another amazing free tool that's designed specifically for them.
PixelPad is built from the ground up to feel like a game development environment. It's got a really clear, step-by-step curriculum that guides students through creating actual playable games with Python. Plus, everything is saved in the cloud, so you don't have to worry about losing all that hard work. It's just a really focused and rewarding way to learn.
So, we've covered the what and the how, but let's zoom out for a second and talk about the why. Because learning this sequence, it's not just about learning Python. It's about building a mindset and a set of skills that are absolutely crucial for the future.
You know, there's this powerful idea floating around that waiting until college to learn a language like Python is, well, just too late. In a world that's being totally reshaped by AI, learning to code is becoming a new kind of literacy. Giving kids this exposure early isn't just a head start, it's essential preparation for the world they're going to inherit and build. The long-term benefits here go so far beyond just coding. This journey develops what we call computational thinking, that ability to break down really complex problems. It sharpens critical thinking skills that are valuable in any field, and it builds a rock-solid foundation for some of the most in-demand careers of the next few decades. Ultimately, it all comes down to this. We can empower our kids to be creators of technology, not just consumers of it. This path from blocks to code is so much more than a lesson plan. It's a journey toward confidence, creativity, and real-world capability. So, the only question left is, are they ready to begin?